All right, so we're going to add these together. So let's call this h of x here. So I labeled h of x in my picture. So we are going to add these two together. So let's see what that looks like when we add these two equations together here. And we get the 2 times the root of x minus 3 plus the root of x plus 1. Now I can't really simplify these two. They're not like radicals, so I can add them together. We're just going to kind of stuck the way this looks. And now what I want to do is try to determine what is my domain and what's my range. So first of all, I want to look at what is the domain of these two, because that's the easy one that we can actually algebraically find out. Sometimes the range is a little bit harder. You may want to just look at the graph to do that. There are some other tricks that we could try to do, but most of the time just look at the graph. That's the easiest way to do it. So like that's how we determine the ranges from the previous ones up there. But the domain, let's try to use algebraically. So what I know is I'm not allowed to take the square root of negative numbers, like I said before. So I want what's underneath the square root, the radicand here, to always be a positive number. If it's negative, that's going to cause problems. 0 is fine, so that's why it's equal to 0. So I'm just going to rearrange this and say, okay, for this equation on the left-hand side, f of x to work, my x has to be greater than 3, equal to 3. For the other side to work, my x has to be greater than negative 1 for that to work. So these are my two domains of my graph here. Okay? Now I want to look at these two domains and think, okay, which one applies here? Do they both apply? Do only one apply? So I'm looking at the domains, and it's just saying that everything from 3 over to the right and everything from negative 1 over to the right works. So you want to look at maybe the negative 1 here and say, okay, if I put a negative 1 on the equation on the left side here, does that work? No, that would give me negative 4. I can't take the square root of negative 4. Can I put the 3 into the equation on the right side here? 3 plus 1, that's equals to 4. So that one works just fine by putting that into there. But I can't put the other one to this. So when I look at these two graphs, and you're going to see this graphically, when I add two graphs together, I'm going to have a graph that starts at 3 and goes this way. Then I have a graph that starts at negative 1 and goes this way. Maybe not dips down like that. But when you add graphs together, if a part of a graph is undefined, so there's a part right here for this graph here, there's a part here that's undefined. So when I add in them, really what I'm adding here, because it's f of x, remember you can interchange that with a y, and this is the y, I'm really just adding my y values together. So you look at my y values and you say, okay, what about my y values? What over in this section of my graph for f of x, it's undefined. There's no y values here. So how do I add my y values together if it's undefined? Undefined plus anything is just undefined. So over here, though, they're both defined. So right here, they're both defined. They're both defined. They're both defined up to this point. Anything on this side is undefined for f of x. So my domain is going to include that. So it's going to say everything for my graph has to be greater than or equal to 3, XCR. It can't be anything less than 3 because that graph is undefined there, so I can't add it. Now, the range is a little bit trickier to try to find. So what you're going to do is you're going to graph it. You can see I already have the graphs here. So you put one graph at the top, and then you're going to add them together. And you're going to look at that, and you're going to see, okay, I'm just adding all my, you can see there's nothing over here for my domain. I'm just adding my y value. So when this graph starts right here, I'm going to add 0 plus whatever this is right here. So that's at 1, 2, 3. So that number we had before, put a 3 into here. 3 plus 1 is 4. The square root of 4 is 2. So they both start here because I'm just adding 0 to it. 0 plus 2 is 0, or sorry, 2. So my graph is going to start at 2 and then kind of work its way upwards there. So I go back here and zoom back to a regular graph. And then you can see it starts here at 0 plus 2. So the graph starts at 2 and goes upwards. Let's go back here. Let's move my face out of the way. So my y is going to be greater than or equal to 2. Y, E, R. Now, it's just easier to find the range using the graph. Okay, so we're going to do the same thing with this one over here. I'm going to subtract these two this time. Same rule applies. You're really just subtracting y values. If there's no y value to subtract, then my domain is going to be limited. So I'm going to have the same kind of domain here, but now I'm going to subtract one from the other. So let's see what that looks like when we graph that out. So go to y is equal to, go to my equations here, and I'm going to put a subtract here instead, minus. Hit graph, and see what that looks like. Okay. So here I'm starting at -2 rather than positive because I want 0, which is the blue graph, minus the red graph, so minus this 2 here. So I'm at -2. So you're just going down and just subtracting all these values. You notice that right here, this spot right here in the middle, both the y values are the same. So when I subtract them, I get 0 as well. Okay? So that's a pretty useful thing to know. So my range here, it's still going upwards if you look at the graph there. Still going upwards. So my range is going to be y has to be greater than or equal to -2 this time. YR. Okay. So let's see what we can do with these other graphs here. So we're going to multiply them this time. So this graph here, I'm going to go 2 times the root of x minus 3. Times that with the root of x plus 1. And when you multiply two radicals that have the same index, you can multiply the radicands together. So I can multiply the two pieces inside here and make it one big radical. I can say x minus 3, x plus 1. If we want to simplify this down, we can. So this will be x squared minus 2x minus 3. Yep, looks pretty good. Because I'm not going to graph that, though. That's what my simplified graph is. I'm going to graph the original graph to help me determine the domain range here. So let's see what these graphs look like and maybe talk about how do we get those domain and ranges after I multiply these. So you're just multiplying your y values together. Okay, so times 2. And then graph. So you can see here, this time the graph starts at 0 because 0 times something is going to be 0. So that's not going to change there. These values just multiply together as you go. The graph is still going upwards. So I can see my domain and range. Again, you're multiplying things, and if it's undefined like it was over before, if it's undefined here, like it was up here when it was up before, undefined times something else is still undefined. So my x is going to have to be greater than or equal to 3 again. But because I'm multiplying it here, my range is going to be greater than or equal to 0, rather than adding. Okay. Here we're going to divide, so we're going to add some restrictions here by doing that. So my new graph here is going to be f of x, so it's going to be 2 the root of x minus 3, that's on the top, divided by the root of x plus 1. Okay. Now, what I'm really just adding here is I'm just adding the restriction that this can't be 0. So x can't be -1. But what we already knew is x could be -1 anyway, because -1 wouldn't work on the top one. So let's just see what this looks like. So you're just going to start dividing the 2. We'll divide here. Yeah, so make sure that's the right order. Hit graph. Yeah. So it starts here. The top can be 0, so I'm assuming that that point is 0. So I can double check that. So at 4, oh, maybe I have to change this table settings here from to before to back to 1. Let's do that. Okay. So at 4, yeah. Oh, my new graph here, I have a value of that. I actually have a value of 3, sorry. A value of 3 because that's what the graph says. Go back to the graph. 1, 2, 3, yeah. So 3. At 3, I have 0. So right there, I have 0 there. Because you're really just dividing 0 divided by 2 and you get 0. 2 divided by this, and you just divided them all. But you notice that if it's undefined to start off with, it's undefined to end up with as well. Okay. So my picture's a bit laggy over there. That's fine. Okay. So I can simplify this down if I wanted to. I can just combine it together as 1 That's pretty much all I can do with that. So my domain is going to be the same as it was before. My range is going to be the same as it was before. So I did, even though I added this restriction of x can't be -1, we already knew that the x had to be greater than 3. Greater than 3. Okay. I'm sorry about my video here. It's just going a little bit crazy. Okay. So let's see what we're doing here. So maybe you just don't watch my mouth while I talk. No, it seems to be going back to what it was before. Okay, so now we have 4 equations here, f, g, h, and k. We're going to all put them together, but this time we're going to evaluate them at certain points. So in this situation here, remember that this is, if it says f plus g of 1, that's the same as saying f of 1 plus g of 1. And then I want to know what that's equal to, question mark. So we just evaluate both individually. So f of 1 is just 2 times 1 plus 1. So that's just this equation where I put a 1 in here. So that means all the x's turn to 1. And then g of x, I'm going to do the same thing. Well, I don't know why I wrote g of x again. Let's get rid of that. So g of x is going to be 1 squared minus 1, 2 times 1 plus 1. So we just do all the math here. So on this side here, f of 1 is 3, and then g of 1 is 0. 1 plus 1 is 2, 0. So overall, my answer is going to be 3 in that situation. It doesn't matter how complex it gets. You can just throw random ones in there. So remember this here, you're multiplying, that's a solid dot. So this is be k of 3 times g of 3 divided by h of 3. I don't know why I didn't put a 3 there. Okay. Then we just evaluate these. So k of 3, so I put a 3 here, but it's just equal to 2. So it's always going to be 2 no matter what. I'm going to put 3 into g here. So this would be 3 squared minus 2 times 3 plus 1. So that's g there. I'm going to divide it by h. H is x cubed. So this would be 3 cubed. Okay, so I got 2 times 3 cubed is, or squared is 9, minus 6 plus 1. So I got 4. On the bottom, I get 27. So this would be 8 over 27. Can't simplify that down anymore, so we're done. Okay, so that's pretty much all you're going to do. So this one here, you're going to multiply f of 1 times k of 1. Then you're going to minus h of 2 times g of 2. So you can isolate each one of these. We already know what f of 1 is. F of 1 is 3. We did the math on that one before. 2 plus 1. I'm going to times it by k of 1, which we already know is 2 because it's a constant function. H is x squared, so this would be 2 cubed, which will eventually turn to an 8, but I'll put that there for now. And then g of 2, I don't think we've done that already. No, is going to be 2 squared minus 2 times 2 plus 1. So 4 minus 4 is equal to 1. Okay, so this is 1, this is 8. This is 6 on this whole side over here. So 6 minus 8. So my answer is -2. There we go. Okay, so that's going to finish off maybe just the first video there. And then for the next video, we will continue on with the examples on this worksheet here. Yeah, I'll see you in the next one. Bye.